This is the demo video of the project that I implemented for the physics-based simulation class. The project is about plotting streamlines using different time integration methods and different time step methods to minimize errors. The data to be loaded should be structured grid VTK data. As external libraries, I used VTK to render streamlines, and I used Qt5 to create windows and widgets. And I used GLM for mathematical operations. First, I am going to build the project by using CMake. Here is the project path and the path for build. First, I am configuring it. And after the configuration done, I am clicking the generate button. So my solution file is generated here. So I'm going to open the Visual Studio. And click the build solution file. So after the build operation has done, my executable file is generated here. So I am opening it. This is the window for Streamline settings. The first one is the direction. It defines where the streamline going to process. If I select forward, it goes in the same direction with this speed vector. If I select backwards, it goes the reverse direction of the forward, and if I click both, it goes both way. The step length is the step size for streamline. I defined as 0.15, and the max step count is how many steps a streamline can take at maximum. So I'm going to define as 600, and streamline count is the number of streamlines to be generated. So I'm going to set as 100. So this is the file path for our data for the streamline. So I'm going to select a file, and this is the integration method. There are two integration methods. The first is Rungekuta and the second is Euler. The other thing is the time step method. You can select fixed or adaptive. If you select fixed, these options are disabled because they are not used for the fixed time step method. And if I select the adaptive, I can set these parameters. In fixed time step method, the step length is always same. In this case, it is 0.15. It will not be changed during the process, but if I change the adaptive time step method, it will change during the creation of the streamline process. So these three parameters decides how our step length will be changed during the creation of the streamlines. In adaptive method, each step computed 3 times. One for the actual step length, one for the half step length, and one for double step length. And it changed the step length by evaluating the process of the streamline. By setting these 3 parameters, we decide how it's going to be evaluated. So the first parameter is the ratio of process of streamline with half step length and actual step length. So it is ideally 0.5, but I can set it as 0.3 to make the streamline more accurate. And the second parameter, maximum step ratio, is the ratio of process of streamline with double step length minus actual step length over actual step length. So it is ideally 1, but I'm going to set it as 0.7 to make it more accurate. And the third parameter, maximum divide ratio. This parameter is how big or small the step size can be. So for example, if you set it to 16, this step size can be 16 or 1 over 16 times of the step length defined. In other words, it can be halved or doubled 4 times. So everything is set, so I can click the generate button to see my streamlines. Okay, so this is the streamlines as shown. So by the way, I forgot to mention the start point of the streamlines. It is by default the longest diagonal of the bounding box here, so all the streamlines starts here. For example, like if I change the direction to forward and generate it again, you can see that the streamlines started from here and processed to the forward direction of the with the speed vector. And if I choose the backward and hit the generate button again, you can see that it only went to the backward direction.